Neptune, the seventh planet in the solar system, is kind of an enigma. It's cold and frigid and might hold some mysteries which have been otherwise unknown. To make it more likely to study Neptune, researchers need to see far-off Neptune more often, which is difficult till this time, as the planet cannot be seen with the naked eye. However, help is coming. The James Webb Space Telescope, the most remarkable space telescope ever built, is supposed to begin operating and observing the universe in June. Circling the Sun around 1 million miles from Earth, it works at incredibly cold temperatures, less than 447 degrees Fahrenheit, which makes the instrument more delicate to changes in freezing places like Neptune. For a long time to come, Neptune will probably keep on being baffling and act oddly. In any case, for some purposes, that is definitively the most awesome aspect of planetary science. The sensational changes are startling on the grounds that they're going on in the midst of a significantly lengthy Neptunian season. It takes Neptune 165 years to circle the Sun, and its seasons last for decades. Like Earth, Neptune pivots on a shifted hub, and accordingly has huge occasional changes because of the distinctions in daylight that the planet gets. Researchers expected such outrageous temperature changes to occur during various seasons. However, presently they're occurring in the midst of Neptune's southern summer. Furthermore, specialists anticipated that temperatures should continuously heat up during this long summer and not cool altogether. Glenn Orton, a planetary scientist at NASA Jet Propulsion Laboratory and the author of New Neptune Research, says, "It's strange. There are a lot of unusual things happening on Neptune which we can't quite understand." What could be driving these uncanny, enormous changes? The answer is rather tricky. However, the research group has a few thoughts. It's conceivable the Sun's 11-year movement cycles might be connected to temperature transitions in Neptune's stratosphere. Or, on the other hand, material changes in the planet's hydrogen-rich air might drive these unexpected adjustments. Planetary researchers need to demystify Neptune, since they've proactively recognized as many as 1,700 Neptune-like exoplanets a long ways past our solar system. Understanding Neptune implies getting a handle on what's happening in other planetary bodies as well. The Neptune that we see is an exoplanet in our solar system. Only one shuttle has ever visited the distant Neptune. In 1989, NASA's Voyager 2 test radiated back amazing pictures of this powerful world, including an Earth-sized storm with 1,000-mile-per-hour winds. From that point forward, planetary researchers have utilized monster telescopes either on or circling Earth to study Neptune, the farthest planet from the Sun. What's more, over the most recent few decades, they've watched outrageous changes in the planet's air. Somewhere in the range of 2003 and 2018, normal temperatures in Neptune's stratosphere, a major layer of the environment lying above tempest and weather conditions, down by 14 degrees Fahrenheit. Then, somewhere in the range of 2018 and 2020, stratospheric temperatures in the South Pole unexpectedly shot up by an incredible 20 degrees. There are heaps of exceptionally abnormal things occurring on Neptune that we don't have the foggiest idea about. The discoveries were as of late distributed in the Planetary Science Journal. Neptune circles a few 2.8 billion miles from Earth, so space experts estimated the planet's temperature change by watching vacillations in its splendor, in a light frequency called infrared, which isn't noticeable to the unaided eye. Voyager 2 arrived at Neptune in 1989. It found 6 new moons, took the very first pictures of the planet's rings, and noticed a particularly brutal storm on its surface. The storm was something of an amazement. In the southern hemisphere, there was wind of up to 1,500 miles per hour, the strongest winds ever recorded. Cosmologists called it the Great Dark Spot, and keeping in mind that it had gone when the Hubble Space Telescope looked at the planet 5 years later, they were keen to know the reason why the winds were so outrageous. They were additionally confused by another issue. Voyager 2 discovered that Neptune is hotter than Uranus, despite being farther from the Sun. Now, this came as a surprise, and the source of this additional heat stays a secret. But this might also mean that we have another puzzle to solve, which could give answers to the origin of the violent wind speeds. Since Neptune is a gas monster, we can't test the worldwide average temperature at ground level in the manner that we could on Earth's strong surface. However, with Neptune's center likely to be small, temperature estimations should be taken at an altitude. But which altitude? We can gauge temperatures in the peripheral layers, and doing so, we observe that Neptune isn't really warmer than Uranus in genuine terms. Instead, they're basically a similar temperature. However, since Neptune gets less sunlight because it's farther from the sun, it cannot have the same temperature as Uranus. So what's heating up the planet? There might be a good reason behind this, but that has to do more with Uranus than Neptune. Scientists estimate that Neptune transmits over 2 times as much heat as it retains from the sun, while Uranus doesn't. And Neptune isn't alone in this. Jupiter and Saturn also discharge 2 times as much heat as they retain. However, Uranus doesn't. Uranus can be said to behave like an oddball in that matter. The increase in temperature as you go farther away from the sun demonstrates Jupiter to be the hottest of the gas monsters. Saturn next, then Neptune. Uranus is the one that is an anomaly. Uranus doesn't have a huge inner heat source, and therefore, as Neptune is figuring out how to warm itself up to the degree of Uranus, Uranus can't actually create any additional heat other than that gathered from the sun. But what is Neptune's heat source? In simpler terms, the heat is what was left over from the time of the origin of the solar system itself, when these planets were formed. The additional heat source on Neptune, Jupiter, and Saturn can also be attributed to a great extent to gravitational contraction. As the planet gradually gravitates, the material falling internally changes its potential energy into thermal power, which is then delivered upwards out of the planet. But if that's true, and Neptune has an inner heat source from the time of formation itself, why doesn't Uranus also have it? Researchers believe that something must have stunted the process at Uranus, maybe due to a collision in its formative years. We already know that heat from a planet doesn't escape from the inside at a consistent rate, but rather comes in bursts. We may simply be seeing Uranus in its tranquil period, while Neptune has burped all the more recently. It could also be an issue of Uranus being much older than Neptune. The amount of heat emanating from a planet depends on how old it is and how rapidly or gradually it delivers that heat. How rapidly the planets discharge heat relies upon the inner construction and organization, cloud layers, convection, etc., and that can be fairly convoluted. However, it can be said that a more seasoned planet is bound to be colder. The inner structure of the planets, their masses, core sizes, and density profiles is critical for understanding the winds as we see them. How the winds structure and how profound they go are some questions that are being answered currently with the help of NASA's Juno and Cassini shuttle. This is because of the very great gravitational information they've acquired, and that implies great models for the inner structure can be made. Considering these new disclosures, researchers are beginning to see Neptune in a totally different light. It will reveal an ever-increasing number of insider facts in the impending future. So this was all about Neptune and the insane discovery that scientists have made. Do like our video and share with your space enthusiast friends. Also, press that subscribe button if you wish to see more interesting videos.